polynomials. The next chapter is all about graphing rational functions. So rational means it's written as a ratio, so it has a fraction in it. So the first thing on that notes handout I just gave you is this definition. When I'm talking about a rational function, we're essentially just dividing two polynomials. Okay, we know what a polynomial is now, so when we divide those, we get that rational function. We do know that in a fraction, what cannot happen?
You can have an x variable on top.
Well, we can have a variable, what can't we have on the bottom?
Zero.
The bottom
Oh.
cannot be 0. So we do have to keep that in mind if I'm talking about domains and things like that. So when I look at the domain, the possible values of x, all we have to pay attention to is the denominator, and we just have to make sure that that does not equal 0. And so any number that makes the bottom 0 will be taken out of our domain. When we're looking at the graph, those are going to be the places where our graph does something a little bit different. So those are the things that will impact our graphing moving forward. First thing I want to do is just practice finding the domain. Okay, so all I'm going to look at is the denominator. And all I need to know is what makes the denominator 0. I know that this cannot be 0, so x cannot be -5. So how would I write my domain if it can be anything except the -5?
Negative infinity to -5. Union -5.
So if I'm looking at this one, my denominator, x squared minus 4, cannot be 0. So how would you solve that? That's where we always do that plus and minus. So x cannot be positive or negative 2. Okay, do you guys know how we would write that? If you wanted to do that with an interval, okay, it's saying it can't be -2 or positive 2. So it's everything smaller than -2, everything between them, and everything bigger. So it's actually 3 pieces, -infinity to -2, union -2 to 2, union 2 to infinity. In general, it does get a little annoying as we start trying to write these in interval notation if there's multiple values that x cannot be. So my expectation is going to be that if it is just one value that x cannot equal, then you must write the interval notation. If it is more than one value that x cannot equal, I will accept either telling me x cannot be this or the interval notation. So I will kind of give you that option. If you have multiple things that x cannot equal, you are allowed to just tell me x is not these things. If it's just the one value, then I do still expect the interval notation because it's not that complicated to write. Everybody understand what I mean there? C. So if I'm looking at this one, my denominator cannot be 0. So that means x squared cannot equal -1. Okay, when we draw a graph, we don't have eyes, do we? So what would I put for my domain?
So weird writing just one set.
D My denominator is 3, so 3 cannot be 0. Does 3 ever equal 0? No. So what's my domain?
Yeah, did we do this last year?
Some of it, yeah.
The asymptote looks weird. I don't know what it is, but
Sounds familiar. That's a step in the right direction. Alright, looking at the last one. What can x not be? So our domain is everything except 1. Negative infinity to 1. Union 1 to infinity. Alright, any questions on that one? So here is a question. That last problem I gave you, x squared minus 1 over x minus 1. What do you notice about x squared minus 1?
you can cancel out the x minus 2.
Okay. So if you reduce that, those cancel and you get x plus 1. So it looks like these are equivalent, doesn't it? The domain. What did we write down for the domain of this on our last example? What's the domain of x plus 1? It has no fraction, so x could be anything. So these are equivalent, except their domains are different. Okay, so they are not identical.
Okay, ever be the same?
They are almost always the same, except at negative or at positive 1. Because if you plug a 1 into the first one, you get that it does not exist. When you put it in the second one, you get a 2. The rest of them, the rest of the graph is identical. They're only different at that one point. We will talk what happens to the graph right here. Actually, what it does is it just puts an open circle on the graph. And we'll look at that. But when I ask if functions are equivalent, their domains have to be the same as well. So it's not enough to just reduce something. We have to pay attention to that domain piece. The domain is based off the original, not what it reduces to. Alright, so now, when we draw graphs, we are going to have asymptotes here. That's what happens when you have things that x cannot equal. An asymptote is a line that we are approaching without actually touching. There are 3 different types. We have horizontal, vertical. What do you think an oblique asymptote would be? Diagonal. Basically, if it's not horizontal or vertical, it's oblique. Sometimes you might hear these oblique ones. They can be called slant asymptotes as well. It just kind of depends on the book. It is possible for a graph to cross over a horizontal or an oblique asymptote, but it will never touch a vertical one. And we'll see that happen as we go through our graphs. Now today we're just going to focus on 2 basic types of rational functions. Remember back in chapter 2 we had all these parent functions and we looked at their graphs. We're going to look at a couple parent functions today and just use those in transformations to look at our asymptotes. So a reciprocal function, 1 over x. Can you tell me the domain of that? Okay, the denominator can't be 0. So our domain would be everything except that. Negative infinity to 0, union 0 to infinity. Alright, range, it's probably a little bit harder to just look at this equation and know. So let's see if we can graph it. Okay. When we didn't know how to graph something, we always made t-charts, right? So if I put in a 1, what's 1 over 1? So 1, 1. If you put in a 2, what's 1 over 2? 1 half. If I put in a 3, 1 over 3. Okay, 1 over 4 would be 1/4. It's just getting closer. Will you ever do 1 divided by something and get 0 for an answer?
No.
Okay. What happens if I put in 1 half? What's 1 divided by 1 half? What's 1 divided by 1/3?
It's
Okay.
never gonna touch the x-axis.
It's never going to touch the x-axis. Will it ever touch the y? Will you ever do 1 divided by something and 0? No. Okay, so this is a curve that's getting closer to the axis, but not actually hitting. Why?
Cause like if you cause if you touch them, she can't run off.
Okay, if you put in -1, what's 1 divided by -1?
Negative
1 divided by -2.
Negative
1 divided by -3. Okay, what's 1 divided by -1 half? 1 divided by -1/3. Alright, so same scenario. We're not actually hitting the axis, we're getting closer to it. These are curves. What we do to show our asymptotes is we draw dashed lines. So the x and y axis here are dashed. We're going to be getting closer to them, but we don't ever actually cross them. So can you tell me the range then, looking at this graph? Negative infinity to 0 union 0 to infinity. Vertical asymptotes. So asymptotes are lines, so you have to give me an equation. A vertical line, what's its equation look like? X equals, and so the vertical line we never hit is at 0. Notice, x equals 0, that's where I broke apart my domain. What's my horizontal asymptote? Y equals 0. Even or odd, I just put it on here as a refresher. We haven't done that in a while. Remember, that's symmetry. Even is the same thing as symmetric to the y-axis. Odd is symmetric to the origin. So if I fold this on the y-axis, does it overlap itself? No, so it's definitely not even. Do that. Odd, if I flip it over the y and the x, does it overlap itself?
Yes.
Yes, so this would be an odd function. Neither. If it doesn't work, then we just call it neither. We also talked about like symmetry to the x-axis, but those aren't functions, so we won't see that here.
Another thing we ended up doing is because this color had this code like variable, so we would block the points.
Oh.
So kept getting
Uh-huh.
spelled.
You put a lot of points on your graph. Alright, so let's say I asked you to graph this one. And I want to give the domain, range, and asymptotes. Alright, think about transformations. We know our parent function is the 1 over x. What happens, what would this plus 1 do to our graph?
Shift the horizontal.
Okay. So if we think, I am going to lightly draw in my parent function here. I am not going to put a ton of points on it. Yeah, so we had like 1, 1. I put in 2, we got half. Put in a half, we got 2. And then the negatives. So this is my parent function, the original. And then when I move this graph to the left one, I'm going to move every point left. If you move left or right, which asymptote gets moved with it? The vertical. So my vertical is now going to be at -1, which we can tell by looking at this. Can you put a -1 in? No, because it makes the bottom 0. So -1 is going to be my vertical asymptote. Does my horizontal asymptote move? What would cause that to move? Yeah, if we were adding or subtracting on the top or on the outside, moving up or down. So then if I just take each of my points to the left, okay, my actual graph is that limit. I asked for domain, range, and asymptote. So my domain is what?
Negative infinity, negative 1, union negative 1 to infinity.
What is my range?
The same. No, never mind.
Negative infinity to 0. And 0 to infinity.
Alright. Then I want my vertical asymptote and horizontal asymptote. I'm just going to abbreviate those VA and HA. So vertical asymptote is x equals -1. Notice, the vertical asymptote goes with your domain. It's your breaking point of your domain. My horizontal is y equals 0. Notice, the horizontal asymptote is the breaking point of your range. So far, so good? Try another one.
These are not
Two parent functions. Alright,
down to
so this one has a couple things. The -2, move it down 2. What does a negative one
Flips
do?
it.
So my parent function, the 1 over x. So we have 1, 1, 2, 1/2, 1/2, 2, and the same thing with the negatives. When I move my graph down, which asymptote gets moved? The horizontal. So it was at 0. If I go down 2, I now have a horizontal asymptote at -2. Did my vertical asymptote move? No, because I didn't go left or right at all. Alright, so if I take a point, when I flip it, where did that go? Just goes across the x, so it's down here. And then I have to go down 2. Okay, so if I had 2 1/2, that would go to 2 -1/2, and down 1/2 2, go to 1/2 -2, and down 2. Same thing on this side. So flipping it, we move it up to the positive, and then go down 2.
just put it.
Hmm. What's my domain?
Negative infinity to -2. Oh, sorry. 0. 0 to infinity.
So what's my vertical asymptote? How do I write it? What's the range?
Negative infinity, -2, union -2.
So So the horizontal asymptote.
Negative 2.
Any questions on that? So I'd like to do the square function, and then just a couple examples and we're done.
So the rest of the page.
What a surprise. Okay, the reciprocal square function. Let's see what this graph looks like. If I put in a 1 over 1 squared. If I put in a 2, 1 over 2 squared. If I put in a half, 1 over 1 half squared.
2.
It would be 1 over 1/4, which is 4. So, will I ever get 0? Can I plug in 0? So we're still getting a similar graph, it's just a little steeper. Same asymptotes there. An asymptote. If I put in negatives, 1 over negative 1 squared. Negative 1 squared would be 1, so 1 over 1 is 1. If I put in negative 2, negative 2 squared is 4, so 1 over 4 is 4. If I put in negative 1 half, negative 1 half squared is 1/4. 1 over 1/4 is 4. So the negatives get squared, so they become positive. It looks like this. So we have a horizontal asymptote still at 0, vertical asymptote still at 0. So what's my domain? And the range? Same thing. No, it's not. Yes, my range, if I look at this graph, we never hit any negatives. So it starts at 0, we don't touch 0, so it gets parentheses and goes up forever. So 0 to infinity. Vertical asymptotes, x equals, horizontal would be y equals. Right, even or odd. Even means symmetric to the y-axis, odd is symmetric to the origin. This is even. If I flip it over the y-axis, it overlaps. Alright. Why don't you guys see if you can draw this? So think about, there's 2 transformations that are happening.
Seriously, where'd you stay? What? How do you know all that?
Yeah, no, we were working on that for hours.
I know, I
5 hours.
What time ago was it? Like 12? Something like that.
Probably got that covered around. I was gonna snap on it. I wish I could have just go.
Sure, I freaking cut up hands.
Alright, so we have our parent function. What are the transformations?
Down 4 and right 2.
Okay. Down 4, right 2. And I knew that it was this shape because of the square. That told me it was the squared one, so it looks like this. Now, if I move down, which asymptote does that move? The horizontal. So my horizontal one is at -4. And moving left or right moves my vertical, so my vertical is at 2. Right, so then I just take my points. Right 2, down. What's my domain?
Negative.
Forward. Oh, then.
Negative infinity to 2, union 2 to infinity.
This one's
Range starts at -4 and goes up, so -4 to positive 1. Last question. If I give you a graph, can you answer questions about it? So it might help us if we drew in the asymptotes. Can you tell where is the horizontal asymptote going to be at?
2.
Well, at
Oh,
2, where's my vertical one at? 2. Okay, so what's my domain? We hit everything except my domain. Negative infinity to 2, union 2 to infinity. Range is everything except 1. So that's negative infinity to 1, 1 to infinity. Can you tell me the x-intercept? Where do I hit the x-axis? Y-intercept, where do you hit the y-axis? Approximately a half, yep. Horizontal asymptote? Horizontal is y equals 1. Vertical is the up and down, and it's the x equals. So my vertical is x equals 2. Do we have an oblique asymptote? No, we haven't really even seen one of those today. We will get to those next week.
Haven't even really.
Those would have to be drawn in for you. So there is a math Excel assignment that's open, and you've got time